Namaste, mere pyare students, and welcome back. I'm so happy to see you. I know, exams are just around the corner. So I thought, chalo, let's do a super quick and powerful revision of this very important geography chapter, water and oceans. And hey, if this little revision session helps you out, you know what to do. Make sure you hit that subscribe button and maybe share it with a friend who's also studying. Your comments always make my day. Now, are you ready? Let's get started. All right, let's kick things off with a super simple question, one you've probably known since you were tiny. Why do we call our home, planet Earth, the blue planet? Come on, you know this one. Think about it. You got it. Because from way up in space, our planet looks like a beautiful, shiny blue marble. And here's the reason why. A whopping 71%, can you believe that? 71% of the Earth's surface is covered with water. And that's what gives it that amazing blue color. So, for today's quick revision, think of this as our little ocean expedition. Here's our route map. First, we'll talk about why we are a planet of water. Then, we're going to take a deep dive to the ocean floor. After that, we'll check out the different temperature layers, uncover the secret of salty water, and finally, we'll have a quick quiz to get you totally exam ready. Ready to dive in? Let's go. First stop on our journey, our planet of water. Now, the number one thing you got to remember here, Butcho, is that water is not just sitting still. Nope, it's constantly moving. Always on the go. And how does it move? Well, that happens through the amazing water cycle. Take a look here. This is the hydrological cycle. You can think of it like a giant natural engine, the engine that keeps all the water on Earth moving around, from the oceans up to the atmosphere in the sky and back down to the land again. And this isn't new. This cycle has been working nonstop for billions of years. It's the reason we're all here, really. Okay, now for the really cool part. Imagine we're all hopping into a submarine, and we're going on a journey deep down to the ocean floor. What do you think is down there? Is it just flat sand for miles and miles? Let's find out. And surprise! It's anything but flat. The bottom of the ocean is kind of like the land we live on. It's got huge mountains, massive plains, and even super deep trenches. It's literally a whole different world down there. Now, for your exams, this is super important. You have to remember these four major divisions. First is the continental shelf. It's the shallow part near the coast, kind of like the shallow end of a swimming pool. Then, whoosh, it drops down. That's the continental slope, like going into the deep end. After that, you have these vast, flat areas, called the deep sea plains. And finally, you get the deepest parts of all, the oceanic deeps. Now, these oceanic deeps, which are also called trenches, are, without a doubt, the deepest spots on our entire planet. And they're really important because they show us where the Earth's giant tectonic plates are crashing into each other. That's why these areas are hotspots for active volcanoes and big earthquakes. It all connects. And just to give you an idea of how deep we're talking, get this. The Mariana Trench is almost 11,000 meters deep. Now picture Mount Everest, the tallest mountain on Earth, right? If you could pick it up and drop it into the trench, the very peak of the mountain would still be more than 2 kilometers under the water. Isn't that just mind-blowing? Okay, our submarine is coming back up. Let's move on to our next topic, temperature. We know the ocean is massive, right? But is the water the same temperature everywhere? Like from the sunny top all the way down to the dark bottom? What do you think? Let's check it out. So, if we're just looking at the surface of the water, the pattern is really simple. The water is warmest near the equator, where it's sunny all the time, and it gets colder and colder as you move towards the poles. That's pretty logical, right? Makes perfect sense. But what happens when we dive down? Well, things get pretty interesting. The temperature actually changes in 3 very clear layers. First, you have the warm top layer, which is heated by the sun. Then, below that, there's a middle layer where the temperature suddenly drops, like really fast. And finally, at the very bottom, you have the third layer, which is super cold, almost freezing. Now that middle layer where the temperature drops so fast, it has a very special and important name, the thermocline. I'm telling you, Bacho, please remember this word. Put a star next to it in your notebook, highlight it. This is a 5-star, super important exam question. The thermocline is that boundary where the temperature just plummets. Got it? Good. All right, we're almost there. Just one more big idea before we test our knowledge. We all know the ocean is salty. You've probably gotten a mouthful at the beach.
But have you ever stopped to think, why? Why is it salty? And is it just as salty everywhere in the world? Let's solve this little secret.
So, the fancy scientific word we use for this saltiness is salinity. And all it means is this: how much salt, in grams, is dissolved in 1,000 grams of seawater. That's it. We measure it in something called parts per thousand. It's a simple definition, but it's super important for understanding the ocean. So what makes some parts of the ocean saltier than others? Well, there are 4 big things to remember. First, evaporation. In hot places, water turns into vapor, but the salt gets left behind, so the water becomes saltier. Then you have rain and rivers. When lots of fresh water is added, it's like adding plain water to your roux of za. It dilutes it, making it less salty. And up in the poles, when ice freezes, it actually pushes the salt out, making the water around it saltier. Let's bring this home with a perfect example right from India. Take the Bay of Bengal. It actually has lower salinity. Why do you think that is? Well, think about it. Massive rivers like the Ganga and the Brahmaputra are constantly pouring tons of fresh water into it. Now look at the other side, the Arabian Sea. It's actually saltier. And why is that? Because there's more evaporation and fewer big rivers adding fresh water. See, it all makes sense when you connect the dots. And just like that, we're done with the topics. That's it. You've covered all the key concepts from this chapter. How are you feeling? A lot more confident, I hope. So, are you ready to lock in all that knowledge with a quick quiz? Let's see what you've learned. Let's do it. Question number 1. Which of these is not a part of the hydrological cycle? Your options are A, evaporation, B, hydration, C, precipitation, or D, condensation. Think about it, socho. And the correct answer is B, hydration. You know the big 3 are evaporation, condensation, and precipitation. Great job if you got that right. Okay, next question. Which one of the following is not a minor relief feature in the oceans? Is it a seamount, an atoll, an oceanic deep, or a guyot? This might seem a little tricky, but think back. What were the 4 major divisions we talked about? And the answer is C, oceanic deep. Remember, that was one of our big 4, which makes it a major feature, not a minor one. See the trick in the question?
All right, last question, and this should be an easy one for you now. Salinity is the amount of salt in grams dissolved per how many grams of seawater? Is it 10, 1,000, 100, or 10,000? Yes, of course, it's B, 1,000 grams, which is the same as 1 kilogram. Perfect. You guys are absolute rock stars.
And that's a wrap. You did it. You have absolutely aced this quick revision of the oceans chapter. I am so proud of every single one of you. Take this confidence with you, keep revising, and you are going to do fantastically well in your exams. All the very, very best from me. And hey, if this helped you, don't forget to like it and share it with a friend. I'll see you in the next one. Bye-bye.